All right, class, next section, 7.7, solving right triangles. So solving a right triangle means to find all the measures of all its sides and angles. Finding all sides, all angles. You can solve a right triangle if you know either two side lengths or one side length and the measure of one acute angle. If you know two sides of a right triangle, you can use inverse trigonometric ratios to find the measures of the acute angles. So finding angles, we're going to have to use inverse trig ratios. So let's talk about those. So your inverse trig ratios. If we let angle A be an acute angle, so we're saying angle A is acute, inverse tangent, if tangent A equals x, then inverse tangent, and this is how we write inverse tangent, it's tangent to what looks like to the -1. So inverse tangent x equals the measure of angle A. And so what is that? If tangent A equals x, so looking at this, here's our angle A. So tangent of that, remember tangent is opposite over adjacent, so tangent A would equal BC, which is the opposite side, over AC, which is the adjacent side. So the inverse of that is down here, or how we do inverse tangent would be down here. And that is going to equal the measure of angle A. So we see up here, BC over AC is to the right of the equal sign. Here we've moved it over and done the inverse tangent, and that will give us the measure of our angle A. So in your calculators, you need to make sure you can find and how to do the inverse of these trig ratios. So if you're in a normal scientific calculator or maybe a graphing calculator, likely you'll have to hit the second button and then the tangent, cosine, or sine buttons. It should show you that inverse the tan -1, sine -1, cosine -1 right above those buttons, or wherever those buttons are on your calculator. That's what you'll do. So you'll probably have to hit the second button and then one of those to do it. If you're using your phone, remember you have to turn your phone sideways to get the scientific calculator. If when you do that, it only shows sine, cosine, tangent, you may need to, there may be like a little left and right arrow at the top left or somewhere on there, and that'll switch to another set of options to press. And then you should be able to see the inverse tangent, cosine, and sine buttons there on your phone. So if you can't find those on your calculator or on your phone, make sure you join me in a Google Meet sometime so we can figure it out face to face rather than just trying to trade emails. So that's looking at the inverse tangent. So same with inverse sine. If sine A equals y, then inverse sine y will equal the measure of angle A. Or same with cosine. If cosine A equals z, then inverse cosine z will equal the measure of angle A. So let's look at some examples of that. Let's put it into practice so it makes a little bit more sense. So we're going to use an inverse tangent to find an angle measure. So using our calculator, we will approximate the measure of angle x to the nearest tenth of a degree. So angle x is up here. We want the inverse tangent. So first we need to find tangent of x. So tangent x equals, so going to our angle x, opposite over adjacent. So opposite is 7, it goes on top. Adjacent is 5, it goes on the bottom. So tangent of x is 7 over 5. So when we're finding the inverse tangent, we multiply that by 7 over 5. So in your calculator, you would punch the inverse tangent button and then 7 over 5. And we'll get the measure of angle x should be 54.5 degrees. And we're rounding to the nearest tenth, so we rounded to 0.5. All right, example number 2. Using an inverse sine and inverse cosine. Let angle A and angle B be acute angles in a right triangle. So if we know we've got a right triangle, we're assuming these angle A and angle B are just acute angles. Use a calculator to approximate the measure of angle A and angle B to the nearest tenth of a degree. So letter A, we have sine of A equals 0.19. So we're getting that decimal there from whatever fraction our two sides made. So remember that one that we just did, we had 7 over 5. We punch that into a calculator, we'll get some number with a decimal, right? So that's where these decimals are coming from. They're just coming from the fraction made by those two sides. So the inverse sine of this will multiply by 0.19. So when you punch that, and then we want to round to the nearest tenth. So inverse sine times 0.19. Oh, just inverse sine, and then punch in 0.19. You don't have to do times. And we should get 10.95, which will round up to 11. So measure of angle A equals 11 degrees. Then cosine of B is 0.56. So inverse cosine 0.56 will give us 55.9. Rounded to 55.9. So measure of angle B, 55.9. And looking at C, we have sine of A equals 0.95. So we'll do inverse sine, 0.95. And we should get the measure of angle A equals 71.8 degrees. Approximately 71.8 degrees. Then letter D, we have cosine of A equals 0.12. So we'll use the inverse cosine. Of 0.12 in our calculators, and we should get the measure of angle A is about 83.1 degrees. So continuing on, solving a right triangle. So we have to solve the right triangle, round decimal answers to the nearest tenth. So remember, solving a right triangle is where we have to find all the sides and all the angles. So anything that's missing, any side that's missing, we need to find it. Any angle that's missing, we need to find it. And just as a little FYI, you can solve more than one way to solve these following problems. So maybe make a little note of that so you don't think you're losing your mind. because we will be able to use sine, choose between sine or cosine or tangent in a lot of cases. So those are the different ways we'll be able to solve this. But let's look at our triangle and let's label what we know. We know our hypotenuse is going to be opposite our right angle. So that's up here. It's our hypotenuse. We're given angle 23, but we also know angle C is 90 degrees. So we wouldn't even have to use inverse of one of those to find what angle B is. We can just add up 23 and 90, which would give us 113. Subtract that from 180, and that would give us 67. So I already know the measure of angle B now. It's going to be 67 degrees, and I just 23 plus 90 gave me 100. All right, I guess I should maybe do it this way. Also, plus B equals 180. So B equals 67. We would just subtract 23 and 90 from 180. So that was one way I could find angle B. I also could have used one of the inverse ratios once I found one of the sides. So I would have had to find one of the sides, and I could have used angle 23. Or I could have used the two sides, sorry, not angle 23. Use the two sides with one of our inverse ratios to find angle B, and it would have given us 67. But we do need to find those other sides. I know this is 67 now. So let's find AC. I'm going to call AC X for this. So looking at angle 23, X is the adjacent side. So I know the hypotenuse is 40, and then I have X for my adjacent side. Adjacent and hypotenuse is cosine. We'll use cosine for that. So cosine 23 equals X, which is my adjacent side, over 40, which is my hypotenuse. Remember, cosine's adjacent over hypotenuse. And then we want to get X by itself, so I'll multiply by 40 on both sides. So 40 times cosine 23 will give me X. So into your calculator, cosine, or 40 times cosine 23. And we get 36.82, so that rounds to 36.8. So AC equals 36.8. So that's another one of our answers. Angle B was one of our answers. Go ahead and erase that and write in our 36.8. And then we just need to find BC. I'll do this in a different color. All right, so BC, if now I'm calling BC X. See, now we've got angle 67 up there, so I could use cosine again if I really like using cosine, or I can use sine of 23. We also have our 36.8, so technically we could use tangent, but since we had to round that to get 36.8, it's better to use our hypotenuse that is not rounded. It's just 40 feet. So I'm going to go ahead and use sine of 23. Which will give me X over 40. Sine of 23 equals X over 40. It's opposite over hypotenuse. And then I will multiply by 40 on each side like we did, solving for AC. So 40 times sine of 23 will give us BC, side length of BC 40 times sine of 23 gives me 15.629, so 15.6. So BC equals 15.6. So lots of different ways we could have gone about finding all of our values. But in the end, we will still get 23 and 67 for our two acute angles, 36.8 for AC and 15.6 for BC. All right, and then the last one, solve this right triangle. Again, we have to find all of our missing angles and missing sides. In this one, we have two missing angles and one missing side. The first one we were missing two sides and one angle. Now we're missing two angles and one side. So we know we need to find angle A. We also need to find angle B. Angle C. And we need to find BC. So if I want to find angle A first, I know that looking at 21 and 43, 21 would be adjacent angle A, and 43 is our hypotenuse. So adjacent over hypotenuse, that'd be cosine. So I might say cosine of angle A equals 21 over 43. Now remember, to find your angles, you'll need to do inverse of whatever ratio you're using. We're using the cosine ratio, so I will use inverse cosine. Inverse cosine of 21 over 43. And that will give me 60.8. It'll round to 60.8 degrees, or right at 60.8 degrees. Measure of angle A is 60.8 degrees. If I want to find the measure of angle C, now 21 is the opposite side, and we still have our hypotenuse. So now this is opposite. So I would use sine and inverse sine. So sine of C equals 21 over 43. So I'll use the inverse sine. 21 over 43. And I'll get 29.2, rounded to 29.2. And then we just got one more thing to find. We have to find our missing side. So in finding our missing side, let's give myself a little more room. We now have our two acute angles, 60.8 and 29.2. So I can use one of those. But I could also, we've got two sides of a right triangle. Why not use the Pythagorean theorem? That'll give us an exact answer, and I won't have to worry that I've maybe rounded in with my angles. So I know that I'm going to call BC x, that x squared plus 21 squared will equal 43 squared. 21 squared is 441. Still plus x squared. 43 squared is 1,849. I can subtract 441. And that gives me x squared is equal to 1,408. And if I do the square root of both sides, square root of 1,408, x will come out to approximately 37.5. So BC is approximately 37.5. And again, I could have used cosine or sine of my angles to find my missing side. But as you can see, since I've got two sides, I can also use the Pythagorean theorem. Just like when finding our missing angle, if we already know two of our angles, we can just use the triangle sum theorem, knowing all three angles add up to 180. That's it on the notes. Make sure you do your homework.